Hello, here we are going to explore how to build a wireless sensor network using a NRF24L01 modules and Arduino boards. We are going to use two modules to send temperature and humidity and one module as a receiver to display the data from two sending modules, so temperature and humidity. The key thing that we are going to learn is how easy it is to build such a network by assigning a unique ID to each module so that we can easily know which module is sending the data to the receiver module. This is very useful for the environments where you need a communication with a large number of different machines and sensors. For this project you will need 3 NRF24L01 modules, 3 Arduino boards, 2 DHT sensors or any type of other sensors, some jumper wires, OLED display, breadboard and Visuino software. Wire everything according to this schematic. First go to Visuino and download and install Visuino program. Start Visuino and select the board. In our case it is Arduino Uno. Add DHT sensor component. Add make structure component. Add NRF24L01 module component. Now select humidity thermometer 1 and in the properties window select the type. If you have DHT11 or DHT22, double click on the make structure 1 and in the elements window drag two analog elements to the left side and close the elements window. Connect humidity thermometer 1 pin sensor to Arduino digital pin 2. Connect humidity thermometer 1 pin temperature to make structure 1 analog 1 pin in. Connect humidity thermometer 1 pin humidity to make structure 1 analog 2 pin in. Also connect both pins to clock pin. Add packet header ID component. Select add packet header ID 1 and in the properties window select ID and click on the three dots button. Here we are going to set the bytes for our unique header. In my case I will set it to 34 and 67. Add at least 2 bytes but no more than 20. Now that we are having a unique ID, you can close the window. Connect make structure 1 pin out to add packet header ID 1 pin in. Connect add packet header ID 1 pin out to NRF24L01 pin in. Connect NRF24L01 pin interface SPI to Arduino board pin SPI. Connect NRF24L01 pin chip select to Arduino board digital pin 10. Connect NRF24L01 pin chip enable to Arduino board digital pin 9. Now upload the project to the Arduino board. Here you do everything the same as in part 1, except change the packet header ID to some other bytes like 3421. The key thing is that the bytes are different than the ones in part 1. This way we can ensure that each sender has its unique ID to send the data. If you are using some other type of sensor, please change it in the properties window. For the second sender I'm using DHT22, so I'm going to change this in the properties window. Everything else stays the same as in part 1, same connections and everything else. Now upload the project to the Arduino board. Add NRF24L01 component. Add detect packet header ID component. Add another detect packet header ID component. Add split structure component. Add another split structure component. Add OLED I2C component. Double click on the structure 1 and in the elements window drag two analog elements to the left side. Close the elements window and do the same for the split structure 2. Now select detect packet header ID 1 and in the properties window select ID and click on the three dot button. Here we are going to add bytes from the part 1. Now do the same for the detect packet header ID 2, but use the bytes from the part 2. You can now see that when the data is coming in, it will be splitted based on the header ID. If it is from sender 1, detect header ID 1 will detect this and forward the data to split structure 1, where we are going to get two analog values, temperature and humidity. And if it is from sender 2, detect packet header ID 2 will detect this. Now double click on the display OLED 1 component and in the elements window add 4 draw text elements and 4 text field elements. Now select Draw Text 1 and in the Properties window set Text to Sender 1 and X to 30. Now select Draw Text 2 and in the Properties window set Text to Sender 2 and X to 85. Select Draw Text 3 and in the Properties window set Text to Temp and Y to 20. Select Draw Text 4 and in the Properties window set Text to Hum and Y to 40. Now select Text Field 1 and in the Properties window set X to 50 and Y to 20. Select Text Field 2 and in the Properties window set X to 50 and Y to 40. Select Text Field 3 and in the Properties window set X to 90 and Y to 20. And final for the Text Field 4 set X to 90 and Y to 40. Close the Elements window. Connect NRF24L01 pin out to Detect Packet Header ID1 pin in and Detect Packet Header ID2 pin in. Connect NRF24L01 pin interface SPI to Arduino board pin SPI. Connect NRF24L01 pin chip select to Arduino board digital pin 10. Connect NRF24L011 pin chip enable to Arduino board digital pin 9. Connect Detect Packet Header ID1 pin out to Split Structure 1 pin in. Connect Detect Packet Header ID2 pin out to Split Structure 2 pin in. Connect Split Structure 1 Analog 1 pin out to Text Field 1 pin in and pin clock. And Analog 2 pin out to Text Field 2 pin in and pin clock. Connect Split Structure 2 Analog 1 pin out to Text Field 3 pin in and pin clock. Connect Analog 2 to Text Field 4 pin in and pin clock. Now connect Display OLED 1 pin I to C to the Arduino board pin I to C. Now upload the project to the Arduino board.